and then we'll do the practical. So we'll do accordingly, because intrusion detection are not it's like the everyone can understand, because there are many things, attacks or something, which we have to see. So first you need to understand about the intrusion detection, and then we can work more on it, right? So let me just share my screen for the intrusion detection. Yes. So let's start with this. We are starting with intrusion detection system using machine learning algorithm, and for this we are going to use Cannon algorithm, right? So now the problem, that is a project which we are going to take, is the intrusion detection system. As we already know, this intrusion detection system is a device or a software application that monitors, we can say, network or system activities, that is for the malicious, or that is we can say for malicious activities or for policy violations. So these kind of things we are using it over here. So this intrusion detection and prevention system, these are primarily focused on identifying what would be the possible incidents or the logging information or the reporting attempt. So that's the need which we have to see. So what actually this is about and what we have to predict. So this is the task, that is we have to build an intrusion detector, and that intrusion detector will predict it, because again we are using some classification problem. So the task is that we have to build an network intrusion detector, that is a predictive model which is capable of, that can distinguish between bad connections and the good connections. Bad connections we are calling it as an intrusion, and good connections we are calling it as a normal connection, right? So we can see this intrusion detection system is a software application or is a device which can detect network intrusions using machine learning algorithms, and you can apply any other algorithm also. And this IDS monitors a network or a system for the malicious activities, and that will protect a computer network from unauthorized access from the users, that include perhaps insiders also, but we can't guarantee that it's from the outsider, we can the insider also, right? So this intrusion detector learning task is that we have to build a predictive model, that is a classifier, so that who is capable of distinguish between the bad connections and the good connections. And the bad connections I told you, that is the intrusions attack, that is our bad connection, and good connection we are calling it as a normal one. So now over here our data set looks like this. So now data set, I'll share the data set with you and the link, so you will see. So first, the things which we need to understand is that we are having millions of record, and over that we have the two labels, normal one and the other four labels which we are having from the data set, that is the DOS attack, probe attack, R2L attack, and the UR attack. So DOS is the denial of service attack. So these are the attacks, and for example synchronization flood. So there are many attacks which comes under DOS. And R2L is unauthorized access from a remote machine. So you are just guessing a password. So that is your R2L attack. And third is the U2R. U2R is unauthorized access to local super user. That is, you are having the root privileges. So the buffer overflow attack is the type, is the kind of the U2R attack. So if you're not familiar with these kinds of attack, don't hesitate with that, because just see, we are having the data set and that we have to categorize. We are having different categories of this. And the last is the probing attack, that is port scanning. In this, if you want to see which port is available so that we can attack on that port. So that is the port scanning. So this is the type of the data set which we are having. And in this, we are having 41 features of each record. Now see 41 features of each record if we are seeing, that is we are having 41 columns. So for this we have to do many filtering, and we have to identify which column is best. So for that we have to perform the correlation also that we have seen in the previous session. So that various things we have to do, and the data which we have taken, it's the real-time data which has supplied by the companies that these kinds of attack they have faced, right? So now moving to next slide. So we have seen the objective function, that is we have to build a learning model classifier which can detect the potential attack type based on the features in connection provided that is in the data set, right? And the data set which I have mentioned the link over here also, you can see it's a KDD Cup 1999 data set. I'll show you the link also, and I'll just paste it into the chat box. Now see over here, the attack falls into four main categories which we have already discussed, that is dog, denial of service attack, and an example is synchronous flood attack. Mainly the flood attack, because when there are a huge number of packets which are coming into your system, so that is a flood attack, and that you can't provide service to the authorized user because it's denied, right? So that is a denial of service. And the second is R2L attack. R2L, I told you, that is unauthorized access from a remote machine. So that is you have to guess a password. So when anytime you're guessing a password from a remote machine, you are accessing into someone account. So that is R2L attack. And the third is U2R, when unauthorized you are accessing to the local super user root privileges. So that is a buffer overflow attack. So this kind of attack is U2R. And prob, that is a port scanning, which I told you. So in this, we are having many files. I'll show you the data set, and there are many features into it which we have to look for also. So if you already know the potential attack in advance, we can just filter the suspicious requests which are coming, right? So that we can avoid the attacks, or we can just terminate the service for the suspicious requests or the attackers which are coming during the connection. So that way we can do. So for this, the framework which we have built for this, first we have performed the data exploration, because the data set which you are having, you have to perform EDA on it. That is the data exploration. You have to check the data set, you have to do the features introduction, you have to perform the data cleaning, you have to divide it, distribute it into the training and the testing part. And then here comes the model. So the model which we are going to use is the KNN, and then we can get the analysis. Okay, what would be the analysis? Okay, might be there is a question. Let me just see. Okay, it's not for me. All right. Okay, so the analysis that we need to done, that is the framework which we are going to build today. Now the data set, I'll show you first the data set link. Yes. First, let me show you the data set, then I'll answer. So see, this is the link of the data set. And over here, and see, this is a real-time data set. So this is the data set used for the third international knowledge discovery and the data mining tools. So which was held in KDD 99, 5th International Conference, Knowledge Discovery and Data Mining. And this competition task to build, they have the network intrusion detector. So over here we are having bad connections and we are having good connections, which I told you. So this database contains a standard set of data which has to be audited, and they have simulated in military network environments. So this is real-time data which we have used, right? Let me just copy this link and paste it in the chat box. Okay. Okay, so there is a difference between, all right. So the passive attack and the active attack. So see, in the passive attack, we are having the attacker observe the messages and then copy it and then save them so that they can use it for the malicious purpose. So that is the passive, they are not doing at that time. And the active is that the attacker modifies that actual information, right? But the passive attack information remains unchanged. So that is the difference between the active and the passive attack. So active and active user attempts so that they can alter your system or your resources, but in passive it just show your data, but it is getting your password also. So it is quite obvious that active one are the more dangerous, but it's not like the passive is not most dangerous. It is, but not at the moment, because they are just copying your data. And yes, we are having vulnerabilities also, and we are having attacks also. So vulnerabilities, we can just say that it's a weakness, right? So what are the weakness we are having into my system, and on the basis of that, attack can be performed, right? For example, this we are saying that vulnerability is a weakness that makes the threat possible, right? And this might be the poor design or the configuration, anything can be there. So if I will take the attack, because it includes sending malicious input to an application, or if we are just flooding a network in an attempt so that we can just deny the service. With surfing, see, you have to deal with the vulnerabilities, because if your system is vulnerable, then only the attack can be happen, right? So you have to see if you have performed the web security or the web audit. So your system, you have to see your website and your web server whether it's vulnerable or not. And there are so many ways in which they will find the vulnerabilities, either with the port or either with the website or either with SQL. So there are so many things which comes under like that, right? And my screen, all right, I was showing this screen. So is it fine now? We'll move toward this. I was showing the data set. Let me go into the data set first. So has any one of you has performed anything on this data set? Yes. Has any one of you has performed something on this data set? Okay. Okay. So let's do it. I have already sent, I think, this link. Let me share it again. So this is the website, this is the data set which you have to take, and when you download it, you can get this. These are the files. So you can see KDD cup names. These are the list of the features, right? And let me go to the features and we'll see. We'll open in a new tab. So the first, these are the features. So there are, I told you we are having 41 features. And over this, you can see the back buffer, the FTP, these are the attacks which we are having. And the first, this is the KDD cup names, the names which they are using. So the duration, these are the name of the columns. So duration, protocol type, service, flag. So these are the 41 columns which we are having. And the continuous mean the value which we are having, that the type is the continuous one. Duration is the length, or we can say the number of seconds of the connection, how much seconds it take for the connection. So the second is the protocol type. So the data is the symbolic. Symbolic means the discrete one, 0, 1, like that. Or the protocol type over here is either the type of the protocol would be TCP or UDP, right? So that's come under protocol type. And the next is the service, that is the network service on the destination. So either HTTP, Telnet. So this again is the symbolic, that is the discrete one. And then we are having source bytes, that is the number of data bytes from source to destination, that would be the continuous value. And then we are having the destination bytes, that is number of data bytes from destination to source. So that again continuous value. And then we are having flag. So flag is discrete value, that is it's a normal one or the error status of the connection. And then we are having land. Land is the discrete value. So one, if the connection is from or to from the same host or the port, or 0, it would be not from the same host or port. So that all are the columns which we are having and its data type. So data type, that is the discrete or the continuous one, the values which we are having. And let me show one thing more. Yes. This is the one. So basic features. So these are the column, that is the feature name and their description, duration, protocol type, service, and the source byte, destination byte, flag, land, and the wrong fragment. Wrong fragment is the number of the wrong fragment we are having in the data set. Urgent is the number of urgent packets, and it should be the continuous one. This is the table one, and the second is the feature name, the hot, that is the number of hot indicators, and the number of failed logins attempt, and logged in 1 if you have successfully logged in, 0 otherwise if you have not successfully logged in. Number of compromised, that number of compromised conditions. Root shell is 1 if the root shell is obtained, 0 otherwise. So in this SU attempt means SU, because in Debian we are using for the root, SU root command attempted. So if they have attempted that command, so it's 1. If they have not attempted that command, then 0. Then we are having number of root, that is number of root accesses they are having. And then we are having number of file creations, then number of creation operations which they have performed. All right. And number of file creation operation, number of shell prompts, and number of access files, that is number of operations on access control files, and number of outbound commands, that is number of outbound commands which we are having in FTP session. And is hot login, that is 1 if the login belongs to the hot list, and 0 otherwise. Is guest login, if the login is a guest login, it's 1. If it is not, then 0. So this is the content features within a connection by domain knowledge. And the third is the traffic features, which they have computed using a 2-second time window, right? And the next is that first the count, that is the number of connections to the same host as the current connection in the past 2 seconds. And these following, and again this would be in the continuous, right? And this would be the continuous one. So second one is the session rate. So the percentage of connections that they have as synchronization error. And the next is the percentage of connections that have rejected errors. And then same percentage of connections to the same service, percentage of connections to the different service, number of connections to the same service as the current connections in the past 2 seconds, and percentage of connections that have synchronization error, percentage of error that have rejected errors. And last one is the percentage of connections to the different host. So see, there are 41 features, and on the basis of that we have to identify and we have to see which feature is important, and on the basis of that we have to apply the algorithm on it, right? And even you can apply the various algorithm which we have studied already. You can apply random forest, you can apply SVM, you can apply decision tree, you can apply logistic regression, and you can apply KNN, right? And you can then see what is the accuracy which we are getting over here. So that is a task which you can do later, but for today's session we are going to do the KNN algorithm. So that is the data set which we are having with us. As a summary, we have seen the 41 feature and one responsible variable. And over this, we have seen the basic features of the individual TCP connections. We are having 9 features. Content features which we are having with the connection by domain knowledge, that are 13. And traffic features computed using a 2-second time window, that are 19. And then we are having responsible variable, that is normal plus 23 different attack types in 4 main categories, which we are having: DOS, RTL, U2R, and probing. And DOS, it contains the back, attack, land, Neptune, port, surf, and teardrop. And you can get all this information in the dataset website and the dataset link which I have shared with you. And R2L, so that because if you don't have much knowledge about the security or the intrusion detection and the attacks, so even then you can also filter this data and you can work on it. So FTP write, guess password, IMAP, multi-hop, this PHF, SPY, and where's it client and where's master, this comes under R2L. And in U2R comes the buffer overflow, load module, and Perl, and the rootkit. So IP sweep, Nmap, port sweep, Saturn, this comes under probing. And the last one, which is we are saying not an attack, that is the normal one. So see the number of training data. So this much of data we are having. And it's a very huge, it's in lakhs, you can see as. And testing data, this is for the training and this is for the testing. And now you can assume how much time it will take, because when you are having data in lakhs, right? So what we need to do for it, that is problem for existing training data set, is that the training data set is too large and it's very time consuming for building models. So for this, we are going to take only the 10% sampling from the data. So now total number of data, as you can see, now it's in lakh, otherwise it's in crore. So 4,94,000 something we are having the number of training data. This is also huge, right? And the problem too is that because there are many duplicate rows in both training data set and the testing data sets. So for that, we have to use the unique values. So we'll remove that. And after removing the duplicate rows, so we are having, see, 1,45,000 something data in the training, and in the testing, 77,000. So we are having a huge amount of data. So this is the distribution that in the data set which we got, the normal, that is the blue one, it's the 60% cases. And Neptune, that is the abnormal, and the other, you can see it's around 39.67. So this is the data which we are having. The 60% is the normal, and almost 40% we can say it's the affected one, that is the abnormal one. Okay. So this is the data which we are having, and the approaches we have to apply, the different algorithms you can apply, but for now we are going to use the KNN algorithm. And for the KNN algorithm, first we'll discuss the KNN algorithm and then we'll move to the other part, right? Let me show you the slides of the KNN algorithm also. Then we'll go to this data set. Okay, we'll go to the KNN now. Okay, is this clear now? The screen is clear?
Yeah.
Okay. Okay, so we'll start with KNN. We'll start with the KNN then. So we are having algorithm that is a K nearest neighbor algorithm. So for this, we'll see. So see, this is again simple machine learning algorithm. Again, it is based on the supervised learning technique. So see this simple example if we'll talk about. So over here we are saying there is a one that you have to tell me about your friends. So who or your neighbors are, then on the basis of that, on the basis of your friend or on the basis of your neighbors, we can judge you that what personality you are having and what you are, right? So on the basis of that, we can just tell. So see over here. So if your friends, so we have to identify this person. So if your friends are always watching movie or always playing, so you are also like that. And if your friends are always studying and get good marks, so if you are with them, you are like them. So that is the thing which we are taking it over here on the basis of your friends and on the basis of your neighbors. So that is we are taking an instance-based learning over here. So for example, if you're having like a phone and we can say if a landline, so okay, it's a phone over there. And if you're having this system, iPad and this laptop you are having, so we can say this system is also a similar, it's very similar to the desktop, this which you have to identify. That is, it's an instance based learning, that is learning from the previous one which you're having on the instance. So that's why we are calling it as an instance based learning. So KNN is having different name. You can use the K nearest neighbor, you can use memory based reasoning, example based reasoning, instance based learning, lazy learning. So these the names we can use. So see, the lazy learning, why we are calling it as a lazy learning over here, because see, the lazy learning is the two things which we are having in KNN. KNN is a non-parametric algorithm and it's the lazy learning algorithm. Lazy learning we are calling because it does not learn from the training set immediately, because instead it stores the data set, it stores the data set, and at the time of the classification it performs an action on the data set. So that's why we are calling it as a lazy learner algorithm, because it does not learn from the training set immediately. Instead it stores the data set, and at the time of the classification when it has to perform the action, then it will perform it. So that's why we are saying just KNN algorithm at the training phase just stores the data set, and when it get new data, so then it classifies that data into a category that is much similar to the new data, right? So for example, you are having an image of a creature that looks like similar to the cat and dog, but we want to know either it's a cat or a dog. So for this identification, you can use the KNN algorithm, and it works on a similarity measure. So our KNN model will find the similar features of the new data set to the cats and the dogs images. Based on the most similar features, it will put it in either it's a cat or the dog category. So that's how it does. So basically, which we have done, that KNN, it's a powerful classification algorithm used in pattern recognition, and K nearest neighbor stores all the available cases and classifies new cases based on the similarity measures. That is the distance function. So we'll see the distance function also. There are different distance functions which we can use. That is the Euclidean, Manhattan, different distance functions we are having. And this algorithm is used as a top data mining algorithms used today. And yes, there is one more thing which I told you, that it's a non-parametric algorithm. It's a non-parametric lazy learning algorithm. Lazy learning I already explained. It's a non-parametric. It means it does not make any assumption on underlying data, because it will learn from the instance. So that's why it is non-parametric, that it will not make any assumption on underlying data. All right. And a new instance, you can see the approach over here, what we are using. So an object that is a green dot, which you can see a new instance which we have to classify. And how we can classify? Again, with the majority votes for its neighbor. So it will go to its neighbor and it will ask from the neighbor, and the neighbors which will tell the output, and it will count the majority, and majority will win. So the object is assigned to the most common class among is the k nearest neighbor. That is, we can find out by the distance function. So as you can see, this is the green dot, right? And this is the new one which comes. And first you have to decide the value of the k. That is how many neighbors you want to take. And how you will take on the basis of the distance, that is the Euclidean or the distance which you have to find it out. So what you will do, if I'll give the k is 3, that is you have to take the 3 neighbors only, so you can check only the 3 neighbors. So what it will do, it will find the distance from the green dot to the blue, the nearest neighbors which it is having from for all, and the distance which is minimum, top 3 distance which is the minimum, it will come under this area, this green dotted one. So now you got it 3 neighbors. So this new dot got 3 neighbors, and A says I belong to class A, and these two says we are belong to the class B. So the majority is class B. So this node will go to the class B. So that is the KNN algorithm basically, right? So now you are having this. So we will tell so how you can actually do it. So see the new record which you are having. First you have to choose the k. That how many. First you have to compute the distance. So this is the new record. It will compute the distance from here to there. This one to this one, this. So first you will compute the distance of everything, and then you will choose what is the value of the k. So value of the k that you will choose, it will take 3 or 5. That is the thing which you need to take. We have taken then it comes under this area, and you have chosen the distance, and you are providing the training record, and then after the distance which we have given over here, on the basis of the distance we can just tell this is the node, and we'll tell the majority. So we have to see what is the majority which is coming under, then it will go. So that's how it is doing. So now here for distance measure for continuous variable, we are having different functions which we can use, right? So we are having Euclidean distance, we are having Manhattan also, and we are having Minkowski also. So there are different functions which we are having. So first you can see the Euclidean one. So this is the formula which they are using. First you have to choose the number of neighbors, that is k value either 3 or 5. Next you have to calculate the Euclidean distance between the 2 points. So Euclidean distance is the distance between the 2 points, as you have already seen in the geometry also, that if you're having a line and you have to calculate this, that is x2 minus x1 square plus y2 minus y1 square. That's how you can give it. I'll write it for you again. Let me write the, yes. Let me open Paint for you. Let me open Word file then. Let me increase the font. Yes. So you are having a line, and you are having the points of the coordinates of the line is x1, comma y1, and then b, x2, comma y2. Okay, so these are the coordinates of your line you are having, and you need to find the Euclidean distance. Size is fine, or should I increase the font? Yeah. So over here, what you need to do, first x2 minus x1. X square plus, that is y2 minus y1, and then square, and whole of the under root. So you have to take the under root of whole. Square root. That is square root. Okay. So that is the formula for the Euclidean distance. So by calculating the Euclidean distance, we got the nearest neighbor. So as the three nearest neighbors in the category A and the 2, you have to find it out, which is you are having. Then only we can say that, right? So that's how this works. And let me just share the other screen. Yes, this one. So accordingly, we are having this Manhattan, and then we are having this Minkowski. So by default, we are applying Euclidean one, and you can apply this Manhattan and the other one also. There is for the different purpose we are using it for it, but you can just apply this one also, right? And this is how first you have to calculate the distance between the new example and all the examples in the training data set, and then you can just find the Euclidean distance between these two examples. And the Euclidean distance between x and y is defined by this, as we have given over here. So now all the instances that corresponds to points in n-dimensional feature space, each instance is represented with a set of numerical attributes also. And each of the training sets which we are having consists of a set of vectors and a class label that associated with each vector. So classification is done by comparing feature vectors of different k nearest point. So then we have to select the k nearest example to the E in the training set, and then we'll assign to the most common class among its k nearest neighbors. And there is one example also that we can cover. So see over here, we are having five customers: George, Rachel, Steve, Tom, and Annie. And we are having these parameters, that is age and their income and number of credit cards and the class. So there are basically two classes, yes or no. All right. And there is another one person that is coming, that is the John. All right. So there is one new one that comes, that is the John person. And the age of John is 37. Income is 50K. Number of credit card he is having 2. So what you need to predict, that is which class it belongs to. Again, it is a category algorithm that you have to categorize, classify it. So we have to see which it belongs to. So for this, and I told you it's a 3KNN. 3KNN means that the K value, it's 3, that it have to check the neighbors 3, right? So first, what it needs to tell, that first we'll need to add 3 is the K value. So we need to find the Euclidean distance. So for finding the Euclidean distance, so these are the points which we are having, and this is for the normal case. So 35 minus 37 square, 35 minus again 50 square, and 3 minus 2 square. So this we are having, and we got the value over here 15.16. Euclidean distance we are using, then 22 minus 37, 50 minus 50, 2 minus 2. Then we got 15. And then 63 minus 37, 200 minus 50, 1 minus 2. So value is 152. And then 59, we are having, so 59 minus 37, same 170 minus 50, 1 minus 2. So we got 122. And 25 minus 37, 40 minus 50, 4 minus 2, and this we have to identify. So we got 15.74. So it said that you need to take 3 because the neighbor should be 3. So we have calculated all the distance and the minimum one. So the minimum distance is 15.16, 15, and 15.74. So these are 3 nodes which will take, that is George, Rachel, and the Annie. All right. And then we have to see the class. So George is saying George belongs to the no class. Rachel and Annie belongs to the yes class. So the majority, we have to see the majority. So the majority belongs to the yes class. So that's why John is also belongs to the yes class. So that is typical which KNN is performing, right? And if you have the problem that how we can choose the value of k, so what would be the value of k that we have to choose, right? How we can say that this value will work better for it or this would be fine. So as such, there is no particular way to determine the best value for k. So we need to try some values to find the best out of them. So the most preferred value for k is the 5, and a very low value for k is the 1 or the 2, because the data can be noisy and can lead to the effects of the outliers in the model. And large value for k, we can say it good, but there would be might some difficulties because you have to process it and they will have to generate it, right? So if it is too small, it is very sensitive to noise point, and if it is larger, it works well, but too large also, majority points may include the majority points from other classes, so that also not work best. And we don't take the even values also. And there is one thing that we don't prefer to take a value even. So tell me, what would be the reason to not get the k value even? Okay, first answer my question, then I'll answer this. Yes, tell me. Can we take even value of k? Anyone? Okay, just tell me, can we, yes, can we take even value of k or not? Yes, we can. Okay, you're saying we can take. It will work. Okay, if we are taking the even value, then it would be good or not? It will work fine. If I'm taking k equal to 4, yes, it will not work fine. Why? Because if we're taking the k value even, because if the k value is even, that is 4, you have to take the 4 number of neighbors with you. Yes, that's the problem with the equal classes. So if a tie is done, then what would be the solution at that moment? So that's why we don't prefer to take the this even value of k. And for KNN, if you are having the overfitted data, so for preventing the overfitting, we can just regularize the regression coefficient. So we have to find the coefficient and we have to do the regressing on it. And that's when we have to find, if we are having noise also, we can just find the increase the number of neighbors so that there might be a region so that we can have just a safe decision or safe space we can just start with. So that's how we can deal with the overfitted data. Okay. And now we'll see this one, and then we'll come to the, okay. Yes, so this is, you can see over here, we are having 1NN, that is a noisy sample, because every sample in the blue shaded area will be misclassified as the blue sample. And if we are taking 3, so every example in the blue shaded area will be classified as correctly with the red one, right? And this is for the one nearest neighbor, you can see it belongs to this class if X is coming. And this is, you can see for the 2 nearest neighbor, because you are having this part. Now see, it's a tie, because one is for positive, one is negative. Now it can't understand what it would take. But in the 3 nearest neighbor, it can see that one is for the negative and the 2 are for the positive, right? So it will belong to the positive class. So that's how they are doing. Okay. So the, yes, for, you can use the cross validation also for that. If you're having the this data. Okay. Okay. So see, if you're having an overfitting data, so for overfitting of data, I said this thing, there is one function that is you can use, and even you can just use the cross validation function also. So you just have to prevent that, you can just regularize the regression coefficient, the coefficient which you are having. And if you're having the prior knowledge about the features, then we can just learn from the weights, and then we can just use the dummy data for that, and we can just provide the cross validation and the feature normalization function for this, so that we can just remove the we are having that data a problem, that is with overfitting problem which we are having, so that we don't have to deal with the overfitting. And even you can change the value of k, so that overfitting can't be done. So it would be a lot of noise, because when you're using k of 2, k value of 2, so that also the chances that the data can be the overfitting. So if you're having any noise data, you can just increase the number of neighbors, so that you can use a region big enough so that we can have a safe decision, right? So now you can see there is, yes, one estimate also, which I told you, that is k equal to log of n samples, which you can take. And I would like to say that you can just increase the k, which is depending upon the noise of the overfitting which you are having in your samples. So that's how you can perform it also. And there are many techniques also which we are using for overfitting, for preventing the overfitting, which I told you, the regularization, this normalization also, even the dropout you can use. So depends on the data also. So how the data you are having, and how you can stop models from the overfitting, and how you can just deal with the outliers if you're having, right? So this method detects outlier just by exploiting the relationship. So that's what we need to do. We have to change the value of k for that. So that is the thing which you can do in your model. Okay. And normalization, now we'll come to that part, right? Yes. Now we'll see the problem first. That is the practical part. Okay, that's done. So let's move to the practical part. For the practical part, let me show you the data set again. Yes, this is the data set, and this is the whole data set, and this is the 10%. And I told you we are working only on the 10% data set. And for the 10%, you can just click on this and download it. And this is unlabeled, this is labeled, and this is the task description. So let me go to the task description also. Yes. So see, in the task description, you can see That is a software to detect, which we have already done, what is the network intrusion and what we need to do. Here you can see all the information that I told you in the slides. Attack fall into four main categories: DOS, R2N, U2R. So these are the categories which, and the probing one also. Four main categories are attack fall to. And over here we have to see the test data. It's not that the test data is not the from the same probability distribution. So it includes specific attack types which might be not, but we are not going to take it. Okay. So derive features. So this we have already seen. So you, if you want to understand the data more, so you can just go with these. And data schema also they have given in machine readable form also. So these are the tables which we have already seen in our data set. All right. So this is the tables, and we have, I already explained the columns and their information. There's a description. You can just go through with this. And let me go to this part. Names we have seen. This is the full data set, and this is the 10% data set. So when you click on it, you can see there is a file which is get downloaded with the extension ZZ. Okay, and this is uncompressed. You can unlabel data. This is the test data and training attack types. We can just see this one. So these are the training attack types: backdoors, buffer overflow, F2P, and these are the back is the category of the doors attack. Buffer overflow attack is the category of U2R, and FTP writer is belongs to the R2L. So this is the category and the attack which they are having. Next, typo correction, which they have a data set and they have mentions the corrections also. We'll see. Yes. So now you can see this is a huge data, and they have, it's an old data set also, because it's not easy to get the real-time data on these kinds of problems. And they have worked because intrusion detection, as you have worked in network security and many other things, right? But it's not easy to work in machine learning, and there is nothing that is in machine learning we can't deal with. We are working with hospital data, we are working with civil data. So there are so many data on which these machine learning algorithms are applying, right? So now let's start the practical first. Let me go with the practical. Let me again write the new Python 3. Yes, and we'll just first let me rename it. Intrusion detection. Now we'll apply on this. So the first is that we have to import the libraries and we have to read these files also. So first, because we have import the operating system libraries for working with this system. And the other library is again NumPy, Pandas, Matplotlib, and the Cbon. Let's run it. And then we have to read the data also. So you can use that value. And for installing the same, I told you. So with this, I have downloaded in this folder. So I'll just open it from.
Kindly increase the size. Kindly increase the font size, ma'am, please.
Oh, yes, ma'am. Yes, sure. Is it fine now, ma'am?
Yes, ma'am, it's fine. Thank you, ma'am.
Okay. So see, over here we are having this import OS with all the libraries which we require. Okay, there is one. Okay, that's from there. All right. These are the libraries. And then first we have to upload the data. So see, we are having the data in my in the download folder. I'll just give the path. And it's in the users. You can just copy the path. So we are having data set, and into this we are having add cup dot names. We'll see first the names are readable or not. Let's open it in a read form as F. And then we'll just print it. Okay, oh, I have to write it in the mode. So that is single mode. Yes, it's done. So now you have seen we have read it. This is the file that is KDD cup note names, and we have downloaded it the folder, and from the folder I have opened this file in the read mode, and we are just reading it and then printing the value which we have wrote, right, and read. So this is the KDD cup names. This is the value which we have printed. Come to this again, and now the columns. So we are having different columns. So you can see the data which we are having, we are not having columns into that. So if you'll see the data, if you open the data, you're not having a columns. So what you need to do, you need to write the name of the columns, and then you have to give accordingly, right? And we are not having the attack types also. We have to write the attack type, and then we can just give it. And then we have to provide the name of the columns also. So that's the thing which we need to do. And you can just open this, see if you'll open in a notepad. So see, this is the value. So this is a ZZ format. That's why it can't work with this. And you're not having a column. So you have to work accordingly. So for this, first we'll write the column name, we'll write the attacks, and that we can just enter it. So I'll do that. So for this, I'll just show you this. Yes. So the next thing which you need to do is that you have to create the columns. So the columns which I want to give it into this, that is duration, protocol type. So these are the columns. Every column we can get it from there. And so first column we have taken as string, we can say list, empty. And then we have taken this column and we are splitting because these are separated by the comma, right? You can see the names which I have put it over here. These are separated by the comma. So you have take one value and you have to use the split function. So the first value before comma which have come, and you can just strip it. If strip means strip function is used for removing spaces, white spaces which you are having. So you strip, then remove, and then what you need to do, just append the columns in that. So in the column folder, we are just appending the column name that we are having. That is the thing which we have done. And then there is another column, that is the target, which we have appended at the last, that we need to find out, that is the category. Now we are just printing what is the length of the columns. So you can see 42 because earlier it was 41, and now we have we have created another column that is with the target which we want to print, which we want output. So that we have appended in the last, and now we are having 42 columns with us. And now we'll see the attack types also. So over here for the attack types, we have used dictionary, right? And for the normal, we are having normal attack. For the backdoor category is the DOS. For the buffer overflow attack, it's U2R category because that's a category which we have to predict. And for the FTP write, it's R2L. For the guess password, it's again R2L, IMAP. So for the everything, because it's available in the information which I have shown you. So we just copy and paste it, and it's in the form of dictionary, key and the value pair. So we have stored it in the attack types. So two things which we have done, first is the column and second is the attack types. So now you can see we have done 4 projects and 4 of are different, and you have to deal with the data differently. It's not like every time the data would be like the same and you have to deal with the same thing. It's not like that. So see, we are doing differently. That's why we are doing different projects so that you can understand better and on the different algorithms. So see the path. So over here, because my data is in the downloads, it's in the Intrusion Detection System Master in the data set. This data set we have just downloaded. KDD Cup data 10% ZZ. So this is the extension also which we have downloaded, right? And over here, you can see that we are just reading the data, that is the path, first variable which we have passed. And the second is that names, because we have to give the name of the columns that it's not there. So names, we have given columns which we have created up.
Ma'am?
Yes?
Ma'am. Scroll once, ma'am.
Yes.
Scroll once, ma'am.
Scroll up.
Yes. No, ma'am. Show once path line, ma'am. Horizontally.
Path? Alright. Okay. I'll show you the path. So see, because I have folder with the name of Intrusion Detection System Master, where I have pasted all the data, even the 100% data and everything, and these files also instead of individual downloading. So that's why I have used this path. Is it clear, sir? Should we proceed further?
Ma'am,
Yes, sir.
so in the last, after downloads, intrusion detection system, after that, just
In my downloads, I'm having this folder, sir. I'm having this folder with the name of
so that file you can keep on document file, ma'am. Better with you.
what, sir?
This entire line you can put into the Word document. Better to understand.
Uh,
Copy it and paste it in the Word document.
I'm not getting what you are saying. Say it again, sir. Okay.
Madam, what you have in the path that you can put it into the Word document, madam.
Okay.
Copy it in the Word document, better.
I'll put it in the chat. This part.
Either that way or this way, no problem.
Okay, I'll put it in the chat box.
ఎక్స్ట్రాక్ట్ చేస్తున్నాను.
Document ఇచ్చినట్టు ఇంకా better. Document.
It's fine, sir. Okay, sir. And now you can see we have read it, and now the data is in again the df, that is in the data frame, the variable. So now we are just reading the value head and see the data. Duration, protocol type, service, flag, these are the values. All right. So over here for the head, you can see 42 columns we are having and the 5 rows. So now we are having the data in this format. So duration, protocol type, service, you can see this. So we'll see the shape also. Now you can see the shape that we are having 42 columns and we are having this much of rows. Or like 94,000 and something like this. So you are having so much of data, and see when I'll apply the algorithm, it will take so much of time also. So now over here, what we need to do, so there is another thing, dictionary I have created with the attack type, right? So what I'll do, I'll create another column into the data frame with the name attack type. Earlier it was 42 column. I am creating another column with the name attack type, and what I'm doing, I'm just using the function in the data frame target, and you have to apply in the target, on the basis of the target, you have to apply this attack. All right. This lambda is a function, it's a user defined function, and over here I'm passing the attack type, that is the dictionary, and I'm telling you have to take the value from the last. -1 is that you have to take the value from the last, and on the basis of that you have to apply it on the target. That what is the target, then you can type okay which kind of attack it is, right? And that is the category which we are just doing it. A target in the target value, so you can see this value we have performed. And now we'll see the data frame shape. So we are having 43 columns. Okay, so earlier we were having 42, but now we are having 43. And I'll show you the data set also at the last. This is the target one, the earlier which we were having, and the attack type. This is the new column which we have added. Why we have added, you will see in a bit. So now the EDA part started, that we have to see whether is there any null value or not. So for that we are having this function is null, and we are doing the sum that is for each column. So now when print it, you can see the value. Every value is 0, 0. That means there is no such null value. That is a perfect, there is no such null value. and just print the data set. These are the data set. And now we are having 43 columns. So first we have to see, because you can see your data is a mixture of this categorical, as you can see the string one, and the we can see the float and integer values. So your machine can only understand the integer type part or float part, that is a numerical part, but not understand the other part, categorical one, right? So first we have to get how many numeric data columns which we are having. So first that with the help of the function get numeric data, and it will apply on the columns, and it will store in the numeric columns. So how many numerical columns which we are having, and in the list we are just getting the subtraction from our total columns. We are just subtracting the number of columns which are having numeric data. So if we are having numeric data, and we'll remove the tag type and the target, because that's our output. Okay, so we are having category columns which are having the categorical data. So this let me just scroll up. Yes, so these are the 3 columns which we are having the categorical data, just removing the last output value, flag, service, and the protocol type. So these 3 columns we are having categorical data. We'll seek the categories. Then we have made the bar graph, so that we can count the value, and we'll just print it for the protocol type. So now for the protocol type, we are having TCP, we are having UDP, we are having ICMP, and the values also we can see from the graph that this category ICMP is having a major share, right? So this is the bar graph which we have made to count the values. And for the flag also, you can see the categories. These are the categories SFSO, and only the 3 categories are majorly used. And the first one, the value SF, this is the highest one. And then for the service also, you can see there are so many services, and which is basically used as this one. And then we are having the attack type. So you can see the DOS, normal, and you can see, so now we are not having more data of U2R. There is a very less data of probe attack, dual attack, and for the DOS and the normal we are having, but majorly we are having the DOS attack, and less amount of data also we are having for the normal. So basically these 2 things we are having in our data set. So we have seen our data set now. So what we need to do, we have seen the columns also, the name of the columns we are having, and if there is any column, so you have to drop that column also if you are having NaN value. So we are not having NaN, but if you want to use it, so you can just use the command drop NA, right? And over here also, so see, we are having so many columns, so we need to find the correlation between the columns. So if we'll find the correlation between the columns, so that we can check which column is to be used or which is providing the same value. So that's what we have done in this code, that is we have find the correlation. But you'll not understand from the graph because there are so much value and this screen is also very large. So for this, what you need to do, you need to just calculate it with the help of the value, the correlation. Otherwise, and in the previous session also, we have calculated the correlation, if you remember. And the correlation I told you, if it is come 1 or 0.99, then we can say it's a highly correlated. And if it is come 0 or negative, then it's not related. And over here, you can see there are the variables which is highly correlated. And those are the columns which we are having as the number compromised and the number of root. So these are the highly correlated because their correlation data output, you can see it's 0.99938. So if you're having these types of value, that category, which we can see the correlation that is highly correlated, then we can say, we can just drop one column. So for this, we are just dropping one column because they are both highly correlated, number of compromised. So we can just drop it for the analysis. So that's why we have dropped this number of root column, and same way we have identified other also. So we have identified the session rate and there is another thing, that is the server session rate. So both are telling the same thing. So just drop this, and we have removed this. And again, the server session rate and the destination host server session rate is again the highly correlated, and the error rate and this destination host error rate is also the same, and then destination host. So just have to find out the correlation value. So you can see we have removed this much of columns. So now we have to see how much columns we are having. So with the have command, so you can see when we have applied just correlation, we have removed, earlier we were having 43 and now we were having 33. So you have removed 10 columns, and that is very huge, right? So now you can see we are having these columns, and because we have filtered it out with the help of the correlation. So correlation is working good for us over here. So now we can, because you are having a categorical data, because the data is in the form of string, and your model will not understand the string part. So for that, what we are doing this feature mapping. We are just giving the name, that is feature, that the values to it. So in the PMAP, in the dictionary, we are just providing ICMP, you have to give 0, and TCP you have to give 1, and for the UTP you have to give the number 2. So we are using this method so that we can just divide our data. We can just, instead of categories, we can just convert it into the numeric form. So the 0, 1, 2, that's what we are doing it over here, and we are applying map function to apply this PMAP over here onto the protocol type column, and we are just defining it to the same. So that's the thing which we are doing, right? And same on the 3 columns were there that we have to give. So see the categories which we have to give: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can give 10 categories also. And the next, the service. So service, this we are having one service column, and it's not telling anything, and it's not making any such we can say effect also on our system. So this is an irrelevant feature which we are having service. So we can just drop it. So that's why we are dropping it. And then we can see the shape. Now we are having 32 columns. Less is good, right? Because 32 is quite far than 43. So next, what we need to do, we need to import the libraries, and we have to split the data set. So over here for splitting the data set, we are using this sklearn model selection, training and test split. And then we are using this scalar function also for the normalization, so that we can just provide the pre-processing, and we can perform the minimization and the maximization scalar also. So that's why we are importing this library over here. And then you can see we are just because we have to create a data frame that is for the X and the Y, right? So for this, we are having 2 values, target and the attack type. So we can just remove the target. So we are just dropping the target column also. So we have just dropped the target column, and then what we have done, so the Y, that is the output which you require, we have put it in the Y. And for the input you require everything, and just remove the attack type. So we have just said in the X, you have just removed the attack type, and you can get everything columns, every columns you can get. So now 30 will goes to this, and this is the 31. Okay. So this is how we have divided with the X and the Y. And then we have applied this minimum and the maximum scalar function. So this minimum and the maximum scalar function which we are using, we are just calling it. And when we are calling it, we are storing it into the variable with the name SC. Okay. I'll explain why we are using this minimum and the maximum scalar. I told you that this is for the normalization which we have to provide. Right. So what actually this will transform features by scaling each figure to a given range. So this estimator will scale and will translate each features individually that would be in the range that we are having. So that we can perform with this, right? So as you can see over here, we are using this min max scalar, and that is for the distribution, that is so that it can scale all the data features in the range which you are providing it. Okay. And now after this, we are just fitting the transform so that this instance which we have defined and the parameters, so we are calling with the fit transform function. So for this min max scalar, if you want to transform it, we have to pass the function fit underscore transform, and it will pass to our data set that you have to create a transformed version of our data set, right? So now our transformed version of data set is created in the X, that is in the form of range. So X train, X test, Y train, Y test, that is the same thing. And now with the help of the train test split function, we are passing this X and Y. And the test size, now over here you can see I'm just giving 0.33 to the test size. So now I have increased it, and instead of applying it, that is 20 to 3, so I'm applying 33% of for the test, and the remaining would be passed to the training. All right, so this is how we have just provide to the X train, Y train, X test, and the Y test. So you can see the data set now also. So this is the X train. So now every value changes into this way, which we want for the scalar, right? So that's done. And X train shape, you can see X test shape also. And now if you'll see that is the time and the accuracy, how much time, because you can see there is a lot of data which we are having, it's in lakhs. So for that, how much time we are getting. So for importing it k-neighbors, because we have to use the k-neighbor classification. So what you need to do, so from the sklearn, again the same library that is for the machine learning we are having. So from that neighbors, you can just import this k-neighbor classifier. Okay. So this is the function we are using it for. And then after this, we have to call this function. We are just calling this function, and we are just storing it in the k variable. Okay. And then we can see and now we are just calling it, and then we have to just use the fit function. Again, the fit function you can use train and for training it. This is done, and then again you can just calculate the score, how many what is the score which we are getting for calculating for doing the training. So this is the score, that is it is quietly performing well for the training part only. And then you can just predict the output again with the help of the predict function that we have done on the X test and that we have stored on this part. And again you can perform the X test also, that is the time how much it is taking for testing it. So you can just run this, and it will take a lot of time because the data set is huge. Okay, X test, all right. I have to just remove the X test. X is the small one. Let's execute this. And now you will see it will take a lot of time. That's why I have shown you like this, because these things take a lot of time. So the same thing we have done for the logistic regression, so that you can compare it. And this is the time which we are calculating for it. So how much time it is taking, because the data I see is very huge, right? And that's how it is taking so much of time. So you can calculate the accuracy, which model is working fine for it. And I have shown you how the k-neighbor works, theoretical part, and this is how it works. And you just have to train it, and you have to just check the time, what time it is using. Okay. Yes, I'll mail this entire file to your email. Just email me on my email ID, sir. Then I can just mail to you that. So any doubt, any question?
Participants, kindly don't send message here individually for instructional material like things. These all are already, we are sending to all the local coordinators. So I hope you people can understand, and the expert, every expert is sending their material to us, and we will forward the same to your respective local coordinators. So kindly manage the material from your local coordinators except the ULEX registered participants. So I hope the instructions are clear to you people. So besides instruction material, if you have any queries, so please you may forward the same to Shruti ma'am. Fine, Shruti, you can send your material of all the sessions to me, and the same I will forward to them, right?
Okay, ma'am. I'll send it.
You need not to send them separately one by one. So it's
Yes,
a tedious
ma'am.
task. So
Yes,
there are
ma'am,
many
I will.
participants.
Yes.
So hopefully they will also cooperate with us. We will forward to the local coordinators.
Okay. Thank you, everyone. Thank you, ma'am.
So participants, if you have any query, you can ask Shruti ma'am. Kindly respond in the chat window, even if you don't have any query, so that we can wind up the session and meet after lunch for the quiz. Okay, fine. Shruti, thank you very much for today's sessions. So the sessions were really informative and full of, practical, hands-on practicals, so that participants came to know about their implementation part also in detail in respective domains. So Shruti madam has wonderfully covered the 4 different case studies with respect to heart attack prediction using logistic regression, pneumonia detection using SVM, and today the sessions covered on crop recommendation using random forest and intrusion detection application using K nearest neighbor. So I hope this might have, given the additional input to think of the different application possible using these machine learning algorithms. So fine participants, now the time is to wind up the session, and we are expecting all of you to be at time 3 p.m. The link will be shared before 3 p.m. to your local coordinators, and I will share here in the chat window also. So either you can open it here from the chat window, or I will forward it to your local coordinators. They will manage at their remote centers. The link will be open, and still if in case any problem you face, local coordinators can communicate, right? So I hope the instructions are clear to you, and we will stay back at 4 for the feedback session. I hope it is clear to all of the local coordinators and the ULEX participants, and we are planning to wind up the course by 4:30. So I hope the plan for today is quite clear to all of you. So now it's a lunch break. You can take a break and see you all at 3 p.m. If possible, we will free you before 4:30, but this is a scheduled plan from our end. Okay, Shruti, thank you very much.
Okay, ma'am. Thank you. Thank you, everyone.